Hello everyone. We are looking at phase 7, chapters vector, exercise 1. We are at question number 7. Now, this question, two vector equations are given to us in, equation of line in vector form are given to us. So, it is telling that two vector equations are given. Actually, if we just understand it is equation of line given to us. And in one of them, there is a constant A. Okay, here is a constant A. Now, given that the lines are skew, find the value A that A cannot take. All right. So again, we have already discussed the conditions for the two lines to be skew. If the lines are skew, then they are not in the plane. The lines are skew. It's a 3D geometry concept. So again, I will just reiterate here very important concept it is. If B1 is the vector, the line, first line is parallel to. If B2 is the vector, the second line is parallel to. And the vector equation of the two lines are always given in terms of the position vectors of the 2 points that lie on the lines. So we have this. So this vector plus B1 vector plus B2 vector. They have to be on the same plane for the lines to be on the same plane. Why? Because this is parallel to B1, the second line is parallel to B2, and these two, they lie on the two lines. So these three vectors have to be coplanar. For the lines to be coplanar, for the lines to be parallel to each other or intersect. But if the lines are skew, that means they are not coplanar. That implies that B1, B2, and whatever this vector is, if this is A1, this is A2, so I'll call it A1 minus A2. So the scalar product, triple product of this should not be equal to 0. Because if this is equal to 0, then the lines are coplanar. This is the condition of coplanarity of three vectors. So what we have to do is simply write the coefficient here. 3, 1, A, then 1 minus 2, 1 minus 1. See, this plus minus 1 is actually, we have to be very careful. 1 minus 2 minus 1, 3, 1, and A. And then A2 minus A1. So my 1 minus 8, so plus 8, so 9. And minus 2 minus, so minus 4. I hope I'm doing correct. So plus 8 minus 9, correct. 4 minus 3, so 1. Okay. So determinant of this should not be equal to 0 for the lines to be skewed. Okay. Let's find out. 3 into. So again, minus 2 plus 4 minus 4. Minus 2 minus 4 is minus 6. And minus 1. 1 minus 9 plus 9 is 10. And then A is minus 4 minus 18. Minus 4 is 14. Minus 14 plus 14. So this is minus 18 minus 10 plus A into 14 should not be equal to 0. So this is 28. So now that implies that A can take any value but 2. A can take any value but 2. Now, given instead that the lines intersect, find the point of intersection. Okay, this concept has already been done before. The lines to intersect, A must be equal to 2. Because if A is not 2, the lines become skew. So we know the value of A, then again the concept, the process is same for finding the point of intersection. Whatever is the point of intersection, write the coordinate in the form of parameters of parametric form. So if this is P, write it as P mu as well as P lambda. These are the two parameters, lambda and mu, and equate them the component wise and find the value of the component. In this case, we'll find this. Acha, ek aur cheez. We need not write the value of A because the two components are enough to give us the parameter. So the value of A, we don't have to. We cannot write it as 2. It should not be 2. It can be any value. for it to be skew. Okay. All right. Thank you.